Hello everyone, today my friend and I are going to present about solving elliptic partial differential equation by implementing 5-point formula. Attention everyone, a situation where hydrostatic pressure can be expressed as the hydraulic head defined at the equivalent height U of a column of water exerting that pressure. In an underground reservoir, steady-state groundwater flow satisfies the Laplace equation that U equal to 0. Assume that the reservoir has dimension 1 km times 1 km and water table height on the reservoir in kilometers. Write down 5-point formula for each node. But before that, we are going to take a look at the introduction of the 5-point formula. The 5-point formula is used to solve elliptic partial differential equation. The elliptic PDE that we consider is the Poisson equation, and if the value of the fxy is equal to 0, then it is a Laplace equation. 5-point formula is a method derived from finite difference method and Taylor series. It is used to find the value of u, x, y at a particular grid point or coordinate. To derive 5-point formula, first we will take a look at the Taylor series expansion around point xi, yj. There are two of them. The first one is Taylor series expansion for u, xi plus delta x, yj, and the second one is Taylor series expansion u, xi minus delta x, yj. After we get the result for both of them, we combine them by addition operation. After that, we will rearrange the previous equation that we get into the general equation of finite difference method with respect to x and y, and then we substitute both of them into Laplace equation, and we will get the result as follows. H equal to delta x equal to delta y. Thus, 5-point formula is as follows. Figure 1 illustrates on how the 5-point formula is. For example, let's say you want to compute at point xy, which represent the red dot. Then you need to know the surrounding point, which represented by the blue dot. After that, you will form a system of the form AU equal to B that can be solved by any iterative method. We are ready to solve the previous real-life problem shown in the previous slide using the 5-point formula. Of course, first we need to convert all the given information into the grid as shown below. And from the boundary condition, we know that this is Dirichlet boundary problem. Let h equal to delta x equal to delta y equal to 0.25. Thus, the 5-point formula is as follows. Now, let's find the 5-point formula for each node. For this problem, the nodes are 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2, 1, 3, 2, 3, and finally 3, 3. First, let's take a look at node 1, 1. Replace the value of I and j, and you will get the following equation. Notice that for node 1, 1, you will get the boundary point as u10, u01. Substitute the value of this boundary point, and you get the final equation for node 1, 1. For the rest of the node, you just need to repeat the same step as you did for node 1, 1, which is to replace the value of ij, find the boundary point for that node, and then substitute again. Summary, we will get the linear system as shown below. from node 1 1 until node 3 3. Since the question only asks you to write down the 5-point formula, then this is it. But if the question asks you to solve, then you will need to continue with either Jacobi method, Gaussian method, SOR method, or any method to solve the linear system. Next, my friend will continue with partial question and other examples. Stay tuned.
Hi, I'm Faisal and I will be explaining regarding the past year exam question. Since you have learned about the concept of 5 points formula, so now let's look how this topic is asked in final exam. Now, let's take a look on the past year question December 2018 question 4. Note that in this question we are required to determine the system of 4 unknowns P1, P2, P3 and P4 for computing approximation for the harmonic function ux, y. In the rectangle R is the function of xy such that x and y is between 0 and 3 shown in the figure under the conditions, ux0 equal to 10, ux3 equal to 90 for x between 0 and 3 and u0 years equal to 70, u3 years equal to 0 for y between 0 and 3 hence find P1, P2, P3 and P4. Notice that for this question we need to solve using the 5 points formula. Note that we want to solve xy plus ue equals 0 under the given conditions in the problem, taking h equals k equals 1. Therefore, by using the standard 5-point formula we have, for P1 equals 1, 1, U2 1 plus U0 1 plus U1 0 for U1 1 equals 0. Then by plug in the value we get U2 1 plus U1 2 minus 4 U1 1 equals negative 84, 1, 1. Then for P2 equals 2, 1, we get U1 1 plus U2 2 minus 4 U2 1 equals negative 10. For P3 equals 1, 2, we get U2 2 plus U1 1 minus 4 U1 2 equals negative 160 and lastly for P4 equals 2, 2, we get U1 2 plus U2 1 minus 4 U1 1 equals negative 90. In summary, we will get the linear equation system as shown. Then, we solve the equations using Gaussian elimination method. The augmented matrix is. Hence by back substitution we get P1 equals 41.19, P2 equals 23.61, P3 equals 61.16 and P4 equals 43.75. Let's continue on the past year question 1996. For this question we need to write the equation for the partial differential equations under the given conditions with delta x equal to 1 over 3. To solve this question first let the second partial of u with respect to x equal to ui plus 1j minus 2uij plus ui minus 1j over delta x square. And let the second partial of u with respect to y equal to uij plus 1 minus 2uij plus uij minus 1 over delta y square. Then we by using the Laplace equations we add both equation then we substitute delta x equals delta y equals 1 over 3 into the previous equation, which then yields ui plus 1j plus ui minus 1j plus uij plus 1 plus uj minus 1 minus 4 uij equals 0. Then by using the 5-point differential formula we get the 4 linear equations where for 1 1 we get u2 1 plus u1 2 minus 4 u1 1 equals 0. For 2 1 we get u1 1 plus u2 2 minus 4 u2 1 equals negative 1 over 3. For 1 2 we get u2 2 plus u1 1 minus 4 u1 2 equals negative 1 over 3 and for 2 2 we get u1 2 plus u2 1 minus 4 u1 1 equals negative 4 over 3. We can conclude that 5-point formula is easy to understand and apply. The Laplace equation is applied in the study of distribution of heat in the body and in distribution of electrical charge in our body. The Laplace equation is unchanged when the coordinates are rotated through 45 degrees.
That's all from us. Thank you for watching.